Hello dear students, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. In this session, I am discussing High Weightage Test 13 most incorrect questions done by the students. This test was based on matrix multiplication. So let's start solving these questions. Let's start discussing those questions. So this question is A equal to cos theta minus sin theta cos theta. Then we have to find the matrix A power minus 50. Okay. First of all, I would like to tell you, whenever you look at this kind of matrix, the first thought that should come in your mind is that first row square sum is 1, second row square sum is 1, and if you take the dot of these two, it gives you 0. So this is a orthogonal matrix. Orthogonal matrix means A into AT is equal to I. Although this is not useful in this question, but it can be useful in some other questions. So please remember this kind of structure in a given matrix, that it will be orthogonal matrix, and it is useful in many questions. So please remember that thing. This question is actually not done with this way. It is done by, if you take this A as, let's say, some function of theta, matrix of some function, matrix of theta, matrix as a function of theta actually. So we can check that if you do A square and you do first row multiplied with second, first row with first column, then first row with second column, and so on, it comes out to be m of 2 theta. So every theta is replaced by 2 theta when you take A square. In fact, if we take A power minus 1, okay, we know it is taken by 1 upon determinant of A into adjoint of A. So adjoint means for 2 into 2 order, it is just interchange the column, interchange the diagonal elements and put minus sign on those remaining elements. It is actually nothing but taking the adjoint, taking the cofactor of each element and then doing the transpose will give you the same thing. And you can see this is coming out to be m of minus theta, because determinant is 1, and you can compare that theta is replaced by minus theta if I compare with original A. So dear students, if we continue this way, and we will find this is actually true for every n, be it negative integer or positive integer. So A power minus 50 will be actually equal to cos of minus 50, which I can write it as cos 50 theta, and then sine of minus 50 theta and minus sign outside also. So sine 50 theta, in this case it will be sine 50 theta with minus sign outside, and cos of 50 theta here. Now we can see that 50 theta, that means 50 into pi by 12 will be equal to 4 pi plus pi by 6, and because cos sine are periodic with periodicity 2 pi, so after 4 pi value will be same, so it is just cos pi by 6, so it will be root 3 by 2, this will be 1 upon 2, this will be minus 1 upon 2, and this will be root 3 upon 2. So that is the answer of this question. So I think the correct option for this is C, root 3 by 2, 1 by 2, minus 1 by 2, and root 3 by 2. Now coming to this question, I think there is some problem in this question. I'll tell you what is this problem. A is given as this matrix, and we are looking for adjoint of adjoint to a determinant. Dear students, the property of determinant of adjoint of some matrix, if we use, will give you adjoint of 2a power n minus 1, that means 3 minus 1, that means square. One adjoint I have removed. Now if you use that property once again, it will become determinant of 2a power 2 whole square. This power 2 is coming when you are removing this adjoint and taking the adjoint of this, taking the determinant of this 2a. So this will become equal to determinant 2a whole power 4. Okay, now this A, because it's a matrix of order 3 into 3, I can bring 2 outside, it will become 2 power 12 into determinant A power 4. So far I think there is no problem in this calculation. I think this should be very much clear to all of you. Now finding the determinant of A, there is a problem here. When I am finding the determinant of this matrix A, and this k or some scalar quantity is multiplied outside, in this determinant I think it should be 1 upon 5, 6 and 7 whole cube. Okay, and then you will be taking, I think, 5 factorial common from first column, first row actually, and 6 factorial common from the second row and 7 factorial common from the third row. And after taking these common, I'll be having 1, 6, 42 here, 1, 7, 56 here, and 1, 8 and 72 here. Okay, so the problem here is that when you are writing determinant of A, this will not be common as it is, it will be common with power 3, because this k when multiplied to a matrix will be multiplied in each and every element. But while taking the value of determinant, it will be coming common from each row, so it will be coming common 3 times. And then when we are solving for determinant, we will be taking 5 factorial common from the first row, 6 factorial common from the second row, 7 factorial common from the third row. So this is what we are getting. Now we can apply some properties. Here it will be 1 upon 5 factorial, 6 factorial, 7 factorial, whole power 2 here. Okay, I can keep first row as it is, that is 1, 6, 42. Yeah, so 1, 6, 42, and my second row I will be subtracting from the first, so it will become 0, 1, and 42, 56 minus 42 is 14. Similarly, third row can be subtracted from the second row, so it will be 0 and 1 and 16. If you simplify it, I think we will be getting 1 upon 5 factorial, 6 factorial, 7 factorial, I think whole square on all over here into 2. The value of this is just 2. Now this is the value of determinant that we are getting. Now if I put this value of determinant here, I don't think any option will be matching here. Actually the problem here is that I think they have ignored this factor will be there. They have ignored this power 3 would have been there. So that is why that's a problem here. So answer would have been something else which is not there in the options. We will make the changes and you will be given with correct options. Okay. So coming to the next question. Now this question, A is invertible. Invertible means determinant value will not be equal to 0 of order n such that adjoint of adjoint A. I think same property we have to use. So determinant of A power n minus 1 square for this thing is equal to determinant of A power 2n square minus 7n plus 7. So because determinant A is not equal to 0, we can compare the powers provided they are not equal to 1 or minus 1. For 1 and minus 1 I will come separately, but let's first only compare the power. So n square minus 2n plus 1 is equal to 2n square minus 7n plus 7. Okay, in this case the value of this will be n square minus 5n plus 6 equal to 0. So n square minus 5n plus 6 equal to 0. This will give you n is equal to 2 or equal to 3. Okay, so there are two values in the case when determinant of A is not equal to 1 or minus 1. Actually for 1 and minus 1 there will be some other cases also. Okay, so far some will be 5. Actually when determinant value is equal to 1, in that case your power can be anything. Your powers can be anything. So you can choose any value of n. Okay. So in that case this question seems to have some problem. So I will say that in this case they should have mentioned that determinant A is not equal to plus or minus 1. Then this question will make sense. Otherwise every value of n can satisfy, because they are asking sum of possible value of n. Actually the possibility of n can be any natural number or any integer if your determinant A is becoming equal to 1. So answer will be C, but this should be added in this question. We will make this change in this question also. Now coming to this question, let alpha be a root of the equation x square plus x plus 1 equal to 0 and matrix A, then we have to find the matrix A power 31. Okay. So dear students, in this case again I will say that you multiply A with A. So this A power 3 we will be getting, and alpha is actually cube root of unity, so omega, and alpha square is another cube root of unity, you can say omega square. Okay, in that case alpha power 4 will be I think omega, and this alpha square will be omega square, obviously baat hai. So this will be equal to 1 1 1 1 omega omega square, 1 omega square and omega, and multiplied with 1 1 1 1 omega omega square, 1 omega square and omega. 1 by root 3 multiplied with 1 by root 3 gives you 1 by 3. So here it will become 1 upon 3. If we multiply first row with first column, it gives you 3. First row with second column 0, and this also 0. Then second row first column will give you 0. Second row second column 1 plus omega square plus omega, this also 0. In this case it is coming out to be 3. Third row first column will give you 0. Third row second column will give you 3, and this will give you 0. So what we are getting, this to be 1 0 0 0 0 1 and 0 1 0. Okay, now if I take a power 4, a power 4 means this a square will be multiplied with the same a square. This will give you I think 1 0 0 0 1 0 0 0 1. So this becomes equal to I. Okay, which means this matrix is actually periodic matrix, you can say. After power of 4 it will give you same thing, like a power 5 will be equal to a, and so on. So if we are looking for a power 31, let me do it here. A power 31, I think it will be a power 28 into a cube I can write. So using this thing it will be I here into a cube. So the final answer of this question will be a cube, that is C. Okay, so that is how this question is done. Coming to, let's do this question. A is given as this, determinant of A is 2, and we are given 2 times adjoint of 2 times adjoint of 2a is equal to 32 power n, and we have to find 3n plus alpha. So first of all we have to find n. I think determinant of A is already given, so n can be found directly from this. Okay, but they are asking the value of alpha also. This will be found when we are calculating the determinant of A using this matrix. So let's do that only first. So determinant of A means it would be 1 2 3 alpha 3 1 1 1 and 2. We may use some property to make certain zeros, or if you feel there is no much benefit of using property, we can open it directly also. Although I can at least make 1 0 here if I subtract R1 from R3. Okay, so this will be 0, this will be 1, this will be 1. Okay, this will be alpha, this will be 3, and this will be 1, and this is 1, this is 1, this is 2. I have made only one change. R1 I have changed with R1 minus R3. You may like not to use this thing because I am not getting 2 zeros in single row, but still at least 1 0 I am getting. So if I open along first row now, so minus 1 will be multiplied with 2 alpha minus 1, 2 alpha minus 1 plus 1 multiplied with alpha minus 3. So this becomes equal to minus alpha and I think minus 2, and we are given this as 2. So the value of alpha is coming out to be minus 4. The value of alpha is equal to minus 4. Now next part. Now here we will be using the property I think we should all know, that is when some constant is taken out from this determinant, and because the order of A is 3 into 3, so when you take this 2 out it will be 2 cube, and then adjoint of 2 times adjoint of 2a. Now the other property that we need to use here is that when we write the determinant of adjoint of something, okay, then it is determinant of something power n minus 1. So it will be 2 adjoint of 2a whole power n minus 1, that is 2 here. Now once again I can take 2 common outside, so 2 power 3 outside. Now if this 2 is taken out, it will be taken 2 power 3 outside, and whole square is also there, so it will be 2 power 3 whole square, and then determinant of adjoint of 2a whole square. Now this becomes 2 power 3 plus 6 2 power 9, and in this case we can write it as determinant of 2a whole square and then whole square. So this will become equal to 2 power 9 into determinant of 2a power 4. So this becomes 2 power 3 I will take out, and then power 4, so 2 power 12 will be outside, so 2 power 21, 9 plus 12 21, and a power 4, and a determinant is 2, so 2 power 4 and 2 power 21, so it becomes 2 power 25, and we are given this as 2 power 5n. 32 is 2 power 5, so the value of n will be 5. So the value of n will be 5. We have found alpha being, I think, -4, alpha being -4, and n is 5, so this will be equal to, I think, 15 minus 4, that is 11. So question, for this question the answer will be D. Answer will be D. Now coming to this question, we are given A is a matrix satisfying the equation A into AT is equal to 9i, where 3i is 3 into 3 identity matrix, then the ordered pair A comma B is equal to, I think this should have been A here. So dear student, in this question I will tell you one direct method, please listen carefully. Whenever we are given orthogonal matrix, here if I divide both side by 9 and I write like this, AT upon 3, A upon 3 into AT upon 3, this will become equal to I. So this A upon 3 becomes orthogonal matrix. Okay, and when it is orthogonal matrix, then in its row as well as in columns we get unit vectors, and that too mutually perpendicular. So 1 upon 3, 2 upon 3, A upon 3, 2 upon 3, 1 upon 3, 2 upon 3, and this is 2 upon 3, minus 2 upon 3, and B upon 3. Okay, so this should give you 3 unit vectors, and they are mutually perpendicular. You can check if you find the magnitude of first row, so square of this plus square of this plus square of this is 1. Similarly here also, if you take dot of these two, this is also, I think, 0. 2 by 9 plus 2 by 9 minus 4 by 9 is 0. But if you do it in rows, then you will be finding that you are getting A and B in one equation, and maybe you can make 2 equations, one taking dot with this and then taking dot with this will give you probably answer for A and B. That can be done. You can check that if I take dot of first row with the last row will give you A by 9 plus 4 by 9 plus 2b by 9 is equal to 0. That is one equation. Similarly, second row with third row will give you 2a by 9 plus 2 by 9 minus 2b by 9, and that is equal to 0. If you add them, this will cancel. This will be 3a upon 9, so this is a upon 3 only. If you add these two, you will be getting 6 upon 9, so I can write this as 2 upon 3 is equal to 0. So the value of a is coming out to be -2. So the value of a is -2, I think B and D option, and if we find, I think, B, you can check, B comes out to be -1. So the answer of this question is D. That is one way. The other method, you can do the same thing in columns also. You take dot of first column with second column. Okay, you take dot of your second column with third column. That will also give you the values of A and B. So both ways you can do it. Also, some people may do, if you do not know this thing, that unit vectors and mutually perpendicular vectors, then you can multiply A with AT, and comparing with the 9i will get you some equations in terms of A and B similar to this only, and then also you can find values of A and B. Here I think it is the same thing they have done, multiplying with A with AT, so these equations are giving you the answer. Coming to now let's solve this question. We are given A equal to this 3 into 3 matrix multiplied with 3 into 2 matrix and multiplied with 2 into 3 matrix, and we have to find A22. Now dear students, please listen carefully. If you apply that strategy or that trick, I will say, you will save your calculation. Please see how. If I multiply these two only, it will be 3 into 2 order matrix, because 3 into 3, 3 into 2, so this will be 3 into 2 and this is 2 into 3. So finally it will be 3 into 3 order matrix. Okay, we are looking for only 2 element. That means final 2 element is what I need, and 2 element will be found if this product second row and second column of this is multiplied. If you call this product as, let's say, B, and you call this as C, so 2 element of B into C will be when you take second row of B and second column of C. So that will give you A22. So I need to know what will be my second row of B. So if I am looking for second row of B, that means it should be found by second row of A multiplied with first column and then second column of this matrix. So second row multiplied with this will give you -2 plus -2, I think -6 plus 0, that will be the first element, and when this multiplied with this thing, so -4 and 0 -16. So that will be my second row. I can write it as -8 here, and not this comma, in matrix we don't put that way. So -8 and -20 here. So this will be my second row of the product of these two matrices. And when this multiplied with second column here, okay, so this will be -8 into -5, so 822 will be 40. So I think answer of this question should have been 40. Okay. Yeah. So that's all for this session. Thank you so much. Bye, students.